All right, let's start up some Eclipse. So you're trying to debug in Eclipse, right? Let's see if we can get lucky. Yeah, it is, isn't it?
You can like look at all the nodes and just click on them. You don't have to write anything down.
Mm-hmm. So what I was hoping to do is find a
You could plug mine in and then you could run the UI.
we could.
I'm down. So my code will be on the screen. I'm fine with that.
Yeah. All right.
How fast from start to finish do you code like a program like PA2?
I don't know, but we're about to find out how quickly we can make a linked list class because they can't find one.
How hard would it be for you to do PA2? Would you be done within like 10 minutes, 15 minutes?
No, probably not.
What about built-in node classes?
Do we have a link list class? Or do we never actually put that on?
I think that was done on the server. So let's just spin together a quick linked list class because this will be useful.
Can you get that? Like,
And maybe you have a linked list that has a node that is connected to another linked list.
Yeah. So we'll make a public static void main. So we'll be kind of lazy here.
Would you press to delete that whole line?
DD.
Oh, just let it. But you're not going to do VWrap. Oh,
Yeah, you gotta have VWrapper.
that's a really awesome.
Do you have it?
All right, so there's our main class. Let's make a linked list class.
I know, right? You never be ahead because something's due the next day every single day. Yeah, I got 75. But it's actually better than what Oh, nice. Did you feel like it was pretty easy?
Yeah, we didn't have any dynamic.
What?
Yeah.
So your next one is going to be a lot harder.
That's fine, I can build one.
That's true. That's true.
That's perfect except for the 80 errors that we've got. So this is just going to be a basic linked list class, right? So we've got a handle, which is the handle. So I use the word handle. Do you know what I mean by that? It's like a handle on a cup, right? It's the thing you use to grab hold of your object. And it could be null if you have no list at all. I don't have a sentinel here. Or if your list exists, it's going to be the first node of the list, right? And if you have access to that, you have access to everything in the list. So handle is sort of a standard term we use for the thing that gives you access to typically a data structure.
Is it what we've been calling root?
Yeah, so it could be called root, or if you had a sentinel node, it would just be the sentinel node. But without a sentinel, right, the handle might be null. All right, so to add a node, we're going to create a new node, and we're either going to set the handle to that, or we're going to set the new node to point to the handle, and we're going to have the handle refer to the new node. And that's a handle. Our print node does that.
So is that node class separate, like it's not inside the other one?
Yeah, I got lazy, so I'm just putting it inside the LL class. You can do that.
He's gonna turn in all 5 classes in.
Yeah, I know. It's a lot cleaner to put them in separate ones.
But we could have had our node classes that are really short.
Right.
On the same one.
So yeah, it's like C where you can have just a running list of everything.
All right, so there's our linked list class. So we're just inserting at the beginning. So let's debug this. So our main program, right, we're just calling our add method. So window perspective, switch to the debug perspective. And then under run, we're going to say debug. But let's throw some breakpoints in. So let's just break at this print method. So we'll say run debug. And we get down to the print method, and we're breaking right there. Okay, we have an object list, which is an LL, right? And it tells me it's an LL. If I click on the arrow to expand that, list has a handle, okay, which is a node. I can click on that to see what this node looks like, and it has a data piece, which is equal to 20, and it has a next piece, which is a node. And I can look at that next piece, and it's got a data piece of 12 and a next value, which is a node. And I can look at that next value, and it's got a data value of 4 and a next value of 0. So in here, I've got my whole linked list, right, sort of spelled out for me. So my handle points to a 20, which points to a 12, which points to a 4, which points to null.
But it works beautifully if it's all working.
Yeah, yeah.
I'm not going to show any of that.
But we can step into the print method. So now we're inside here. So we've still got we've got the handle, and we don't need to expand that at this moment. But let's go ahead and single step. So we'll step over, which is F6. So we create this variable temp, which is equal to handle. And if we were to look at temp, right, we could do the same thing and run down the whole linked list.
Where was your step if you don't
From
have...
temp. I used F6, so it's under run step
okay, run.
over. So temp is equal to the handle, and we can see that it's not null, and we can see also that it's actually, it's not just a node, it's node number 20, which is the same ID as handle, so we know it's actually the same object as handle. Okay, so that's useful. and then we can step. So it's going to do our print line. There's our print line result. Now we're going to say temp equals temp.next. Well, if we expand temp next should be node ID number 22. So if we step, this should change to node ID 22, which it does, right? And it highlights variables that change. And now temp's data is equal to 12, right? So that's the second node. It's still not null when we call print line. It prints a 12. And temp's next is 23. And 23's data is 4. So when we step this, we should see that temp changes again, changes to node 23, and its data value is 4. Right? So we're just kind of like stepping through, we're examining objects and looking at the fields that make up those objects. And we can set breakpoints, we can continue until another breakpoint, and all the usual stuff. But at this place, it's most useful really for kind of looking at your structures. So you got a word list, which is a big linked list, and each of those nodes in your word list has a linked list of integers, a position list, right? And this can help you take those apart. You still may need to write some things down on a big sheet of paper, but if you've got, you know, the first node of your list pointing to null, even though you've added a bunch of things, that's going to jump out at you right away. You can see that something went wrong in connecting your pieces of your list. And so you go to where you think you're inserting your second node, and you single step, and you watch what's happening to your variables, and at some point you'll see that something that should have pointed to your new node is still pointing to null because you forgot to write that line of code, or you used the wrong object name or something. So the biggest burden is still on you, right? But this kind of helps with visualizing your data to go along with pictures.
When do you not need a constructor?
You need a constructor. Yeah, so I skipped a constructor in my linked list, right? There's always a default constructor. It takes no arguments and it just returns your object. But if you want to do some particular initialization, you can do it in a constructor. You never really need one. I could make a method called initialize. I could construct to just get me an object, then I could say object.initialize and run whatever code I want. But if you're always going to do that, if that makes the most sense, you can put that code inside a constructor explicitly. And typically it's when you want to pass some arguments, right? So I could, in my node class, I could make a constructor that takes a piece of data and sets the data field equal to that, sets the next field equal to null. And then up here I could have just said node new node equals new node parentheses n, and I could have skipped these two lines. But it's kind of up to you as a designer.
So if you said node, new node, and then you just didn't say, could you not say new and then have that constructor bit there?
Say again?
For where you declare new node,
Mm-hmm.
do you need?
Oh, up there.
Yeah. Do you need to say new node?
Yeah, so if I just say node, new node, it's not even going to compile because it's going to warn me that this hasn't been initialized.
Oh,
Right? In reality, at this point, new node is null.
okay. Mm-hmm.
And so this would give me a null pointer exception.
It's
If I
just saying it doesn't want to mess with anything if it's not.
It can't, right? Null does not have a data field. Null does not have a next field. It's a little weird because we're saying that new node is a node, right? And nodes have data and next fields. But this particular new node is null. So it doesn't have those fields. It's kind of a strange syntactic, gibberishy kind of thing.
You set it equal to null there and still mess with it?
If I set it equal to null, it will compile, right? But if I run it, I'll get a null pointer exception. But I could say new node equals, and here I could construct right? And that does the same thing as what we had before. But it's got to have some value somewhere. Right now in C, we can say, you know, integer I, and I exists and it has a value, right? But we say the value is unpredictable, it's gibberish, right? In this case, when we say something like integer I, and it doesn't work with lowercase integer, right? But in the case of a class, right, it's actually equal to null until we give it a value. And it kind of stops you from being able to use its value, which might be random gibberish, right? It'll actually throw an exception until we construct a node.
Because I think that's what I was getting mixed up on, because like, you didn't make a constructor, but you're still calling the closed parentheses.
Yeah, there's a default constructor,
Okay.
right? Because everything comes from an object, and objects have constructors. But I would say it's probably a good habit to make constructors. Right, so now I've written my own constructor, and it literally doesn't do anything different from the default constructor. But it's still a constructor.
There was a discussion on end of line when you're doing input.
Yeah.
And I kind of don't know what the consensus is. What works?
So Control Z, so on Windows,
Yeah.
on Windows, Control Z, beginning of the line, hit Control Z and hit Enter. That should register as end of file.
It's super buggy.
Yes.
It'll work the first time through, but if you try to do it again, you have to like click on your code
Yeah.
and then click back and do
And it's
it.
apparently been buggy for several
It's
years.
Holy mother.
Yeah.
I think I fixed my problem.
Okay, cool. So when I test this, I'm going to use a main program where I redirect standard in. Okay, and I posted something on how to do that. And that should always reliably generate end of file when you hit the end of whatever you're redirecting from. So that's what I'm going to use to test this. And you can do the same thing, right? If you have a small text file that you want to use for your input just in your main program, use that system call to set up standard in, and then you don't have to mess with Control Z, Control D.
I'm so excited right now. It's not
Got it working. Cool.
You know when you finally get it working?
Was that the whole problem, was Control Z?
Yeah.
Oh, okay.
No, it was actually the creating it. Basically, you know how first you create a word list, and then you want to also add a position to that.
Mm-hmm.
So apparently I wasn't creating a position list before doing the add
Okay.
to that list.
Right.
You know?
So you're getting a null pointer.
And then so all I did was create a position list or whatever right before the add line.
Cool. Awesome. Yeah.
That's the question. I'm getting a lot of warnings, like my code works, but I get a lot of these warnings that say, hold on. The value of the local variable is not used.
That's okay usually,
Okay.
I have to make my
unless it's not. So if you do something like you know, here's some method, and somewhere in here I say something like integer x equals 7, and I never use this variable x anywhere in my code, that's going to generate that warning. Okay, and it may be harmless. It may be that you had a variable that you intended to use and you just didn't get around to it, or it may be that you meant to do something with this and you didn't, and it's actually telling you you've got a problem in your logic, right? So don't just dismiss it, but think about, you know, if this is like something that I wanted to do something with, it's telling you you're not doing anything with it anywhere in this code.
Okay.
And that might be a big warning that you used the wrong variable somewhere or forgot an expression or
One
something.
time I think it was upset because I had
It's just type. This is
pointer, or I was using a variable as a pointer to something,
Mm-hmm.
and it was saying I wasn't using it anywhere, but I was using the variable, but I wasn't using it at what it was originally
Right.
pointed to because I changed it later and then used it.
Okay.
Yeah, so
Sometimes you can trip up the compiler into thinking something's wrong when it's not, right? Like not having a return value in a section of code where you know it's never going to get to, right? It'll complain, that kind of thing.
Yeah, mine was complaining about having two constructors. Like, you know, in PA1 we had the, if it
Yeah.
has a denominator and if it doesn't.
Mm-hmm.
I had one where, and I'm not sticking to this idea, I don't know if I like it yet, but I had one constructor if it has a word and then one for just making the thing.
That should be fine. It should let you have two, as long
Yeah,
as the
it would-
signature is different, which means the argument types.
Yeah, and so when I made a new variable of that type, it was like, you didn't pass it a string. Like, and then it was like, do you want to make a constructor for this? And I was like, I have one.
So it didn't see that other one as a constructor
Yeah.
for some reason, so it might have been spelled slightly differently, or maybe it was inside something else or
Yeah.
something.
I also went through and renamed a bunch of things because I was confusing myself
Mhm.
with my naming, and it now just works.
Okay.
I didn't change anything else otherwise.
Yeah.
So it could have just been something I wasn't seeing.
Okay, interesting. All right, good. Other discussions, questions?
I think I missed, how do you set a breakpoint in the debugger?
Yeah, I missed that.
Oh,
You can
Um,
set it alive.
I just kind of go on the side and double click in the source code.
Okay.
So just over here in the margin, you can double
okay.
click.
That did it.
Right click, I think. Yeah, right click, I think, and also separate form.
Okay. Alright.
Or I'll give you like a little.
So I did a left click. What is a right click? Will give you a context. Yeah, so you can toggle or you can disable, leave it there, but make it inactive, and so on. And that can be anywhere in the number area.
Okay.
I didn't even initialize the word. I just created a variable.
Well, let's talk about PA3. And this is going to lead us nicely into talking about painting with swing. So PA3 is going to be a tic-tac-toe game. Yay. And this is a one-page assignment, so it's deliberately unwordy. And I'm describing in here sort of the minimum details that you need to do to be able to get full credit on this assignment. But there's this huge galaxy filled with possibilities that you can use to extend this project in ways that you like. Okay? This is a chance to really dig into the swing classes, the graphics class, playing around with colors, playing around with events, right? So if you want to take this a lot further than the bare minimum, this is an opportunity to do so. Okay, I'm always telling people, write code, write code, write code, but it's like, what should I write? Okay, so here's a very specific example of things that you can write. You've got 2 weeks for this. You definitely want to get this part working, but if you work on it, you know, several hours for a few days, you should be able to get this done pretty well shy of 2 weeks. Okay, which leaves you time to either go do physics or to dig into some of the other details of this, right, or both preferably. So let me tell you what the minimum is, okay, and when I say minimum, I'm not underselling this. This is a lot of work, okay, there's a lot going on here. But if you do what it says here, right, you can get full credit. But then we'll talk about other things you can do. Okay, so raise your hand if you know how to play tic-tac-toe. Okay, if you don't know or you don't want to raise your hand, talk to me and I'll explain it to you. So basic board game, right? And here's what you want to do in a nutshell. You're going to draw a tic-tac-toe field of battle. And you're going to do this inside a J-frame, and you're going to have various options, such as who goes first. Is it the user or is it the computer? do you want to be X or do you want to be O? The user gets to choose. Okay, so me, U, X, O. So you can use radio buttons or whatever. But you want some way to display tic-tac-toe board and let the user specify options. Which mark do they want? Do they want to go first or should the computer go first? And you want some kind of start button. Shall we play a game? All right, so let's say that the user wants to go first and they've decided to be X. So they put those selections in, they hit the play button. Nothing happens until the user clicks somewhere in the field. Okay, the program's just sitting there. You can put a timer in if you want to like make the user nervous. You can make a ticking sound or something. But eventually the user comes over and they click. Let's say they click right here. You draw their mark in that position. And then it's the computer's turn. So you run whatever you're going to do to have the computer decide where it wants to move. Okay, this can be, you know, something with deep learning. You can like tap into Google's network or something, or you make a random move or something in between. You're not required to make a good tic-tac-toe player. Okay, and if you want to pick a totally random square that's legal, that's absolutely fine. Okay, but if you want to play around with how can I make a game that never loses, right? Have fun with that. It's a really good setup to do that in. Okay, and it's not that hard to learn how to win tic-tac-toe. I taught myself in 6th grade to try to impress Susie Warren. It worked, I guess. I don't know. She gave me a cupcake next Valentine's Day. So, all right. So, so the user makes a choice. You draw their mark, and then the computer decides what move to make. And at some point, it draws its mark in the square it's chosen. And now you go back to where you were a moment ago. You wait for the user to click somewhere else. And they click here, and the computer thinks about it, and it makes a move like right here. And then the user makes another click. And each time that you move or the user moves, you need to see if the game is over. And the game's over if all the squares are filled up and nobody's won, or you know, if there's a diagonal, horizontal, or vertical line. At this point, it sees the game's over. It draws some kind of, you know, diagonal line to indicate where it is, and it can say something like, you know, you won the game and the game's over. And the user can now, you know, change their selections if they want. They can hit the play button again and start a new game. It'll clear the field. They can make a move and so on. Okay, that's the basic setup. Nothing deliberately weird. Okay, very, very straightforward. Or just imagine playing a tic-tac-toe game. But there's a lot of details in there, right? So, so it's supposed to be a GUI. I want you to use swing to do this. Way to choose who goes first, way to choose the mark, some sort of start button to start the game. If the computer is not going to make its move instantaneously, if it's going to take a while to think about it, you want a way to say whose move it is right now. Say like it's the player's turn to move, or the computer is making a move, please wait, or something like that. Usually the computer's move is instantaneous, so it's always basically waiting for the user to click. Tic-tac-toe board, a way to figure out if the user's clicked on a square and then draw the user's mark, a way to detect when somebody has won or when the game is over, and a way to start the game after it ends. But there's a lot of sanity checking to do. Okay, for example, you're playing the game and the user's about to lose, they shouldn't be able to hit the play button and start over. Okay, that's a cheat. So this play button should be ignored while the game is going on. And maybe if they try to click the play button, you can say something like, you know, if you want to surrender, I'll accept your surrender or whatever, or just ignore it. If the user tries to move in a square that they've already moved, that's illegal. If they try to move in a square that the computer has already moved, that's illegal, right? And if you don't check for these things, right, I might click here and it might just go ahead and put my mark there because that's where I clicked, right? So you got to check and make sure that's legal. If I click somewhere outside the playing area, I shouldn't put a mark over here, right? So make sure that they're clicking inside, you know, this region. And if they click here or here or here or here or here, right? You want the mark to be centered in that box. Okay, so basic sanity checking. Just the stuff that seems reasonable, right? And after the game ends, don't let the user keep picking squares, right? So that they end up winning after the game is over. And all of this means that this is a stateful system. It has a number of different states. So if you just think about your plain tic-tac-toe board, and let's say the user clicks the mouse right here, what the program is going to do in response to that depends on the state of the system. If we've just started a game, it's going to draw an X there. If there's already a mark in this spot, it's not going to draw an X. It's going to give you an error message or something. If the game is over, it's not going to draw a mark. It's going to say something like, please hit the start button to begin a new game. Right? So the same action, and when you click here, your code is going to jump down into one of these event listeners, and you're going to find yourself in some little snippet of Java code inside some class. But what you do in there is going to depend on what situation you're in. So you're going to need to keep track of the state of the game. Is there a game in progress? Which squares are filled and which marks are they filled with? Right? And depending on the answers to those and possibly other questions, your response to a mouse click is going to be different. So it's not the kind of program that you can write like you would do in a C program, where you say, get the user input, make some decisions, generate some output, go back to the top of the loop, right? There's no loop which says, wait until the user clicks on something, now take their XY position and do the following. The reality is, most of the time, your code is not going to be running. When they click, you're going to start executing a piece of code. It's going to draw a mark and change some variables, some state information, and so on, and then it's going to exit. And most of the time, it's not your code that's running. It's the background code that Swing is running for you that's just kind of sitting around waiting for events. And when somebody clicks the mouse, it's going to call some piece of code of yours, and you'll do something. Okay, but it's all going to be event-driven. So think calculator program, think the last few ODPs, right? And you're going to have to structure this, and we'll talk about ways to do this, but you're going to have to structure this to be event-driven instead of just procedural. Does that make sense? So like high-low is the opposite, right? You asked for the user to make a guess, they typed in a number and hit enter, and then your code continued and said that's too high and went back and they made a guess and so on, or vice versa. In this, you're really just kind of like the system's waiting for something to happen. And when something happens, a mouse click, a button press, whatever, your code's going to jump in at that point. But it's got to be prepared to deal with that event, and how it's going to deal with that depends on what's already happened in the past. So you're going to have to keep track of all of that. That's the whole state aspect of it. All right, so write all that, put it in a zip, upload it to Eclipse. 2 weeks from Friday, you're good to go. So that's the basic setup, and like I say, it's a very short description, right? 1 page. Because there's lots of flexibility. So you don't have to have a smart AI. You can make random moves as long as they're legal. You don't have to use color. You can do this all in black and white if you want. You're not going to lose any points for that. Okay. But, you know, if you want to play around with color, this is a good opportunity to learn how the color model works and how to colorize components and so on and so forth. Let me tell you the one simplification I do not want you to make, though, because there's always a few people who try to do this. Don't make 9 buttons and lay them out in a tic-tac-toe board shape and just click on the button and that's a move, and click on the button and that's a move. Okay? I'm not going to let you do that. So you're going to want to pick up mouse clicks using a mouse event listener. Look at the XY coordinates, figure out what square they clicked in, and go from there. Okay, we're going to talk about how to do all of that. But the lower ball way to do this is just put 9 buttons on there. Click the buttons. I'm going to consider that a cheat. So.
That was the only way I was thinking of how to be able to do it.
Yeah, yeah. So
So now I'm lost.
that's a simpler way, yeah.
Could we have a mouse click event listener for each square?
You can. So you could make 9 squares. That's going to complicate things though when you try to do things like draw a line through those and stuff. So the way I'm going to recommend it is you have one panel here and you get an XY position, you figure out which of these 9 areas you're in, and we'll look at some numbers for that, and it's a pretty simple algorithm once you get down to it. And then your painting and stuff is straightforward, more straightforward. All right, so that's the basic setup. Before we can do any of this, we got to talk about painting. We've got to talk about how do we draw this tic-tac-toe board, how do we draw an X or an O or a line through these marks, and so on and so forth. And this was where I was 5 minutes before the end of the earlier section yesterday, so I'll spend 5 minutes doing the same thing I did for them, and then we'll take a break and we'll come back and we'll start looking at doing painting in the graphics class. But let me spend 5 minutes. How many people here have interacted with an old school TV set with a big cathode ray tube in the front? The kind you turn on the power button and it takes about a minute for the picture to come on. Okay, so you've got some experience with this. So so old TVs, right, they had this horrible, fabulous thing called a cathode ray tube. It's this big vacuum tube. Okay, picture a light bulb, but you know, 16, 24 inches, whatever the size of your TV screen was. And this was the screen you were looking at. Okay, very hard to make flat. That's why old TVs were curved. And it's a big vacuum, so there's almost no particles inside. And the surface of this, so it's a two-dimensional surface, is covered with a phosphor. Okay, a coating that will glow if you hit it with energized electrons. Okay, normally it's basically transparent, so you look at the screen, you don't see anything. But if you hit a beam of high energy electrons at some point on the screen, you get a little dot that lights up. Okay, so how does this work? You have an emitter back here, a piece of metal basically that you run current through and it heats up. And as it heats up, it glows and it spits off electrons. Okay, and electrons are charged particles, and it turns out you can steer these things with a field generator. So we put a pair of metal plates here above and below, and by applying a field between these plates, we can deflect that beam up and down. All right, so your beam is coming out of this piece of metal, and it hits this thing and it bends upward. And now it's going to hit the screen up at this point. If you turn off this field, it's going to hit the screen right in the middle, and if you reverse the field, it's going to bend down and hit the screen closer to the bottom. So we can light up a dot up or down based on the field we apply to these two plates. Now you take another pair of plates and you put them on each side, and you use that to steer the beam left and right. So now if you look at the front view, we've got this two-dimensional area. We can take this electron beam, we can deflect it up or down with those first plates, we can deflect it left, right with the second, we can steer it. We can cause that beam to hit the screen anywhere that we want. So how do we make a picture? Well, we set the fields to move the beam to this upper left corner, and if we want to paint a dot there, we turn on the electron generator, and we'll get a little glowing dot right here. And now we steer the beam slightly over to the right, so it's right at this location, and we get a dot here. And now we steer it a little more, but we turn off the beam generator, and so we have a black spot here. And we change the field to move it over here, and it's still black, and when it gets over here, we turn the generator back on, and we get some more dots. And when we get all the way over to the end, we drive that first field back, and we change the second field to bring it down a little bit. So now we start drawing on this second line, and then we draw on the third line, and we keep doing this. And when you're done, you've got a shape. And as you're sweeping across, you come back, you go down lower and lower and lower until you get all the way down to the lower right corner. Now you turn your beam off, you reset both of your field generators, you fly back to the upper left corner, and you do this again. And you do this 30 or 60 times a second, and by changing which pixels are on and off, you get images, and they move, right? So that's old school TV technology. The same concept kind of applies to our modern displays, except there's no electron beam, there's no vacuum tube, and so on. But we still think of our display as being broken into these regions that we call pixels, and each pixel can be turned on or off. And by changing which ones are on or off over time, we get moving pictures. If we just make it static, we have a static image, right? But there's pixels all along this line that are turned on, okay? But there's, 1024 by 768 pixels showing on this screen right now. So it looks like lines, but it's, of course, just a bunch of very small dots. And if you allow this phosphor to have different colors, you can imagine 3 beams, a red, a green, and a blue beam. And where the red beam hits, you get a red dot, and green gives you green, and so on. And if you have 2 colors close to each other, like red and blue, both turned on, your eye will see it as purple. So you can start mixing these colors, and by using a high energy beam or a lower energy beam, we can control the intensity. So we can mix different combinations of red, green, and blue and get a whole range of different colors appearing on the screen. Okay, so those concepts, they don't really apply to how an LCD panel works, but that model is still kind of it still works for interacting with, say, doing graphics from the swing class. Okay, so let's take a 5-minute break, and then we'll talk about how we actually do some of this painting of objects on a J-frame.
You just made me puke in my mouth a little bit because that's exactly what I've been talking about in physics.
Oh, really?